Welcome to the Math Record. Today I'll be covering the ICTM 2021 Division AA Geometry, which I'll answer questions 6, 9, 10, 11 in this video, and then questions 15, 18, and 20 in the next video. As usual, I'll scroll down all 20 questions if you want to answer these beforehand, and I'll provide the answers at the end of the video. Okay, let's begin with number 6. Determine the sum of the degree measures of the angles with the vertices at A, B, C, D, E, and F of this polygon shape. So let's draw a rough picture. So something here, 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 up, here, and connect these two. Okay, so what we could do is just recognize some triangles. So using this triangle, a thing about triangles is that if you add two vertices, the exterior angle of these two, which is this one, of the opposite, is going to be the sum of those angles. So this one plus this is equal to this, which is a pretty neat fact. So this plus this equals this. And we could do the same thing with another triangle. So this triangle right here. So using the same idea, this vertice plus this vertice is equal to this exterior angle. I didn't draw this triangle pretty nicely, so it's kind of hard to tell. So this one plus this one equals this. Okay. And now we got 4 of the angles. Now we just need these two. So this and this. But we actually don't need to find these two because using vertical angles, this angle has to be the same as this angle. And this red angle has to be the same as this angle. And these 4, because this one is just these two, and this one is just this two, which give us all 6 of them. In this one quadrilateral, this quadrilateral is 360 degrees like all quadrilateral. So that is our answer. And it's just that simple. Okay, question number 9. The numeric area of the region bordered by the x-axis and the parabola y equals x squared over 9 minus 1 is 4. Determine the numeric area of the region bordered by the x-axis and the parabola y equals 9 minus x squared. So there are 2 ways you could probably do this, more if you want, but 2 of the common ways, which is first you could use a calculus using an integration, but that's usually if you're like a junior or senior, because this is a pretty easy question for them. But if you were a sophomore, like a freshman doing this, basically you're just probably going to use an idea with observation. So first, I observe that the fact that using this parabola, our y-intercept is at -1, and we have a positive coefficient, so that's going to be concave up. And I know that this parabola is 4. The area is 4 between this parabola and this x-axis. Now I claim that this parabola is just 9 times bigger than this parabola. And to see that, all you have to do is just rearrange these terms. So that's negative x squared plus 9. So I didn't change anything. All I did was just find the area, just find a different way to write it. Now I'm going to divide this by -9. So negative x squared divided by -9 is x squared over 9. And 9 divided by -9 is -1. And as you see, this is exactly the same thing as our previous equation. So what this -9 tells me is that this new equation is this parabola, but just flipped over. But this 9 tells me that it's flipped over and 9 times bigger. So if this parabola is 9 times bigger, that means this area, which is 4, compared to this area, has to be 9. This area has to be 9 times bigger than this 4. So 9 times 4 equals 36. And that's our answer for number 9. So you just need to observe that fact. You just need to figure out that fact, and it'll be a pretty easy question. Okay, question 10. Determine the exact distance between the two lines 20x plus 21y equals 10 and 20x plus 21y equals 24. So to solve this question, generally, if you don't really know what to do, you could just find a perpendicular line to these two lines, which is what they wrote down. And then this perpendicular line, you could find these 2 points, and then that intersect from this perpendicular line, and then find the distance between them. But a different way you could do this, using the idea of vectors, is that you could find 2 points on this line, on each of these lines, and connect that distance, and then from that line, we could just find this distance straight down. So to do this, you're going to actually have to use something called vector projection. So first off, before we do this vector projection, let's find that line. So first we need to find 2 points on each of these lines. So let's just set the x equals 0. It doesn't matter what 2 points they are. So 10 divided by 21, that's our first point on our line, or second point on the second line. 24 divided by 21. Okay, so we got 2 random points. Doesn't matter which points, as I said earlier. Now we need to find the distance between these two. So 0 minus 0 equals 0. 24 minus 10 equals 14 over 21. So 14 divided by 7 equals 2. 21 divided by 7 equals 3. So the distance, the vector between these 2 points is this vector, 0, 2/3. Now we gotta find, now when you use something, vector projection, so we just found 2 random points. To find that vector projection downwards, we need to find a vector that goes down this way. And luckily for things like lines and planes, the vector, this vector, which is called a normal vector, is exactly the coefficients for those lines. So in this case, it'll be 20, 21. And now we could use the vector projection formula, if you know it. Let's just label this, so UV. So the vector projection formula is U dot V divided by the magnitude of V. So U dot V, so that's 0 times 20 is 0. And then 2/3 times 21, that is 21 divided by 3 is 7. 7 times 2 is 14. And the magnitude of V, so that is square root 20 squared plus 21 squared. So that's 14 over 20, 21. Take the square root of that, you're going to make a Pythagorean triple. And this actually is a Pythagorean triple. It's 20, 21, 29. So this is the 21. You could use a calculator to verify this, but it's true. So our answer is 14 over 29. And that is our answer for number 10. Now number 11. Square ABCD and EFGH are congruent with point E, the center of the square ABCD. The shaded area represents the overlap of the two squares. The ratio of the numeric area of the shaded portion of the square EFGH to the non-shaded area of EFGH is K to W. So determine the ratio K to W. Okay, so let's just draw this picture. And then we have another one. It's rotated like this way. Okay. So we need to find the ratio between this shaded section to this non-shaded section. And what I'm going to do first is that I'm going to make a line from this vertex to here and here to here. And I'm going to make the claim that this area is exactly the area of our shaded portion. So to do that, this area is the same as this, as I claimed. Basically, all I had to do is claim that this section is equal to this, because this is our overlap. So to do that, all I need to notice is that this line is the same as this line, which makes sense because it's a square. So these diagonals have to be the same. And basically, I know that this area angle has to be the same as this angle because this is a square, so this is 90 degrees. But since we cut it right in half, because this is what this diagonal does, this would be a 45 degrees. This is 45, which is the same case here, 45, 45. Okay, and the last thing I need to do is just prove one more thing, which is side or angle. And I'm going to prove this angle is the same as this angle, which is pretty similar, which you could do pretty easily. This is 90 degrees, so that means this angle plus this angle has to be 90 degrees, but this is also 90 degrees since this is a square, so this has to be by these two diagonals. That means this angle plus this angle has to be 90 degrees. But we just said that this angle plus this angle is 90 degrees. So that means since they share this angle, that means this angle and this angle has to be exactly the same. So now we found three things that are the same. So this angle is the same as this angle is the same as this, and these two angles are the same. So that means this triangle is exactly the same as this triangle. That means the area of this and this is the same. So that completes our proof. That means this area is the same as our shaded area. And by the property, let's draw that again. Since we cut it right here, we cut this here and here. This area is just a fourth of the entire square. So this square is exactly the same square as this square. So that means this area is a fourth of the entire square. So that means if this is shaded, this will be 1 out of the 3. Because this will be the red. Because 3 plus 1 is the 4 for the total. So the shaded to non-shaded is 1 to 3. And that's our answer for number 11. So it's just more of a proof question than actually math for geometry. Well, thanks for watching. And here are all answers for all 20 questions. Okay, so in the next video, as I said, I'll cover questions 15, 18, and 20.